A1, Pythagorean theorem and its converse. If you look at theorem 8.1 here, it talks about the Pythagorean theorem. It says if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. If triangle ABC is a right triangle, so they're telling me this is a right triangle, then if there are two legs, A and B, A squared plus B squared equals C squared. Okay? There are some few common Pythagorean triples that are just pretty easy to look at. 1's 3, 4, 5. So if you have two legs, 3 and 4, you know the hypotenuse is 5. 5, 12, 13. 8, 15, 17. And 7, 24, 25. Problem 1, find the length of hypotenuse. What is the length of hypotenuse? So again, identifying the hypotenuse is key. I draw an arrow from the box there. That points me to my hypotenuse. So AB is my hypotenuse. We'll call that C. Why is it called side C? Because it's across from angle C. Notice it's a lowercase as opposed to an uppercase. That's how you know that they are. So I'm going to go C squared equals 20 squared plus 21 squared. Punch in your calculator, you end up with 841. Take the square root of both sides. I end up with C equal to 29. And as always, it's really plus or minus 29, but we're talking about the side of a triangle, so it's just going to be positive 29. Problem 2, you want to find the length of the leg. So again, let's identify my hypotenuse right there. Okay? Hypotenuse is 20, so I start with that. 20 squared equals x squared plus 8 squared. That gives me 400 equals x squared plus 64. Subtract the 64 both sides. I end up with x squared equals 336. Take the square root of both sides. I get x equals the square root of 336. Now, we've got to break that down. Again, look for the biggest possible perfect square that goes into it. I'm going to take that and break it down into the square root of 16 times the square root of 21. So x is going to give me 4 times the square root of 21. A2 is the converse of the Pythagorean theorem, and it talks about if the sum of the squares and lengths of two sides of a triangle is equal to the square of the third length of the third side, then the triangle is a right triangle. So in other words, it's just saying if you have the Pythagorean theorem being true, it makes it a right triangle. So this one talks about identifying a right triangle. A triangle has side lengths 85, 84, and 13. Is this a right triangle? Well, what's the biggest side? Hypotenuse is the biggest side, so I'm going to take 85. Is 85 squared equal to 84 squared plus 13 squared? Well, again, it's just a calculator way. You end up with 7,225 on the right, and you end up with 7,225 on the left. So they're equal to each other, therefore it's a right triangle. The next two theorems, A3 and A4, talk about also C squared equals A squared plus B squared. We talked about it being a right triangle. In A3, they talk about C squared being greater than A squared plus B squared. If that's true, it's an obtuse triangle. If C squared is less than A squared plus B squared, it's an acute triangle. So again, there's three types of things there. So you're classifying this triangle with side lengths 6, 11, and 14. So again, identify the biggest side, 14. Is 14 equal, or 14 squared equal to 6 squared plus 11 squared? So I'm going to punch those again. Punch them in your calculator. You get 14 squared, which is 196. Is that equal to 36 plus 121? Is 196 equal to 157? No. In fact, 196 is greater than 157. So if it's greater than, we know that the triangle is obtuse.